Hello everyone, this is Nesteris and I'm going to be covering the basics of programming. We won't be doing code per se, but we will be covering the concepts so that we can start on the code later. Okay, so when we cover programming, it's really split into two groups. So over here we have the concepts, and over here we have the syntax. Now, under concepts, we have just everything we can kind of do in programming. So maybe variables and functions and so on. And under syntax, we have how to write it out. So we're going to be focusing on this box for this tutorial. And we can't really talk about programming or any concepts until we cover how to work with data. Because if you can't work with data, you can't really do anything at all. Data drives programs. So it might be helpful to be able to store data. And storing data is done with variables. Now in something like Lua, all we need is the variable name. So once you have that, you're set, just like in standard mathematics. And then with the name, we can use what's called an assignment operator. That's just equals, and then we can put a value in there, like 5 or high or 2.1, whatever we want. We could even put other variables in there. Now in JAS, the name's not enough. Not enough. Because JAS needs to know what kind of values can go into this variable. And over here we actually have 3 different kinds of values. So a variable declaration includes a type and a name. The type says how big the data is and how that data is interpreted. Okay? And JAS does include quite a few types for us to work with, and later we can even make our own types. And the basic types are just integer, real, string, and boolean. And this will be kind of our most basic data. So for integer, we have whole numbers. For real, we have decimal numbers. For string, we have words, sentences, letters. Pretty much whatever we want. And for boolean, we just have true or false. So I also talked about size earlier. That means that integers can only go down to a certain amount and up to a certain amount because integers have a limited size. So the minimum is some really big negative number, and the max is some really big positive number. And you can use any value in between these. What happens when you go out of this range? You end up going into what's called an overflow, and all that happens is the sign will flip. So if you were positive, now you're negative, and if you're negative, now you're positive. The same thing happens with reals. With strings, you get a crash. Just Warcraft 3 will crash. And booleans, you only have two values to work with, so you don't have to really worry about size at all. There's no constraint. So let's try declaring a few variables here. So we said we need a type and a name. So I could write out integer O. That's valid right there. Or real M. Very creative names. And then we talked about the assignment operator earlier. I could do O is equals 7. JAS does require an extra word here, set O equals 7. And the other thing I can do is I can actually use the assignment operator as I declare the variable. So I can give it an initial value of 9. Now, storing data just in single little variables like this is all fine and good, but what happens when we want to deal with something like players? There are 16 players, and we probably don't want to make 16 different variables. So we can make what's called an array, and an array is like a variable with slots. And you get 8,192 slots. So it's like making 8,192 variables all in one go, and you can access them with a number. So you can look at variable number 5 or variable number 1, whichever one you want. And this will be useful later on. Early uses is we could have like a bool array, a boolean array. And we could say like, is the player nice? And I'm just going to call this player nice. And then we could say player 0. And this is how you access it. So the very first player is player 0. Is not nice. We can do a set up here. And now if we want to see if player 0 is nice or not, we just look at this position using the player ID and see what the value is. So just one immediate use. So how do you declare these suckers? Well, you need your type, just like before, and you need your name, just like before. But now we have a new piece in here, and that is the array keyword. So actually when we declared it, or did an example earlier of this, that was an actual declaration. So for example, integer array name. Or probably not name Bob. That'll work. And how do we set these suckers? Well, we can't just do set Bob equal 5. Because now we have 8,192 Bobs. Which Bob do we want to set? Well, this doesn't tell us which Bob we're setting. It'd be kind of cool if this set all the Bobs to 5, but life isn't that nice, so we have to say which Bob we want to set, and we do that with these little brackets. And then here we put in the position. And so we could say set Bob 19 equal to 7. Perfectly valid. Now, there are 8,192 positions. But the first position is not 1, and the last position is not 8,192. It's actually 0 and 8,191. Still 8,192 positions. It just starts at 0 instead of 1. Now, why does it start at 0? Well, there's another way to actually look at arrays here. If we say that, so we're talking about back to our data, and here let's say is an integer variable. An integer variable will have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, and so 32 little things inside of it. So that's what an integer variable looks like. And these would be like your zeros and ones. So 0, 1, 1, 1, 0, for example. And that would actually give you the integer variable of 14. Well, the integer value of 14. We'll cover that conversion later on. So you have 32 of these suckers in one integer variable. Now, if you want to look at an array, suddenly you have 8,192 of these things, and not only do you have 8,192 of these things, they are all right next to each other. So I'm not going to draw all 8,192 boxes, but this would be your first box, your second box, your third box, and your fourth box. And it just goes all the way down until you're at your 8,192nd box. It's just this really long row of boxes. So when we think of an array, the variable itself doesn't actually store 8,192 things. All the variable stores is the start of the data. So it would store the very beginning of that first box. So here's box 1, and it stores this position right here. And if we're thinking in terms of bytes, because all the data is actually stored in terms of bytes, not bits, this single box would actually be 4 positions. And so the next box, if this started at memory location 0, this would start memory location 4. So 0, 1, 2, 3, 4, 5, 6, 7, 8, and so on. So it increases by 4 every time. You don't really need to know this, but this is telling you why it starts at 0. So we're going to get into the actual reason now. If the array stores that first position, stores this, then array plus position times, we can call this the word size. So an integer is 4 bytes, so word size is equal to where you want to go. So yeah, the position you want, or data you want, rather. Why am I scribbling that out when I have an eraser here? Data you want. Okay. And to see that this works, let's say our array starts at 1656, and we want to go, this is an integer array, so word size is 4, and we want to go to position 5. So 1656 plus 5 times 4 is equal to 1676. So this is where our 5th integer starts. Well, 6th integer starts. Our first integer starts at position 0, so 1656 plus 0 times 4 is equal to 1656 itself. So the first integer, the first value, starts just at the array beginning. And that's why we use 0. So that's why arrays start at 0, and why they end, in the case of Jess, at 8,191. Kind of a long explanation, but it works. So let's look at what we covered so far. We covered that a variable declaration has two components, a type and a name. And a variable array declaration has three, so your type, then the array keyword, and then your name. You can initialize these with values, at least this kind right here. So for example, with the value 6, you cannot initialize this, and then you can assign them values later on using the set keyword. So set name is equal to 7. Or for arrays, set name. Then you need your position is equal to 9, for example. There's one last thing you need to know if you actually want to start coding this in JAS, and that is blocks. Kind of another important thingamajig. Blocks are just sort of regions of code. So you have a start and you have an end. And everything in the middle is part of that block. Okay? In JAS, every block has a name. So for example, globals. And then that name is what you actually use to start the block. And then all this stuff in here, everything underneath globals, all the following lines would be part of globals. Okay? How do you end this block? Well, you do end, and then you do the block name again. End globals. So inside of globals, you can declare variables. So we could declare an integer s, a real r is equal to -1, whatever we want. Now we cannot do sets. That will not work. All we can do in a globals block is declare variables. That is it. Nothing else. There are other blocks, but we will be getting into these other blocks in another tutorial.